Barbara McClintock, The Woman Who Heard the Corn Speak, 1902 to 1992. In the fields of Connecticut during the 1920s, a young woman knelt among rows of maize, her hands covered in soil, her eyes shining with curiosity. While others saw only plants, she saw a hidden language, patterns, rhythms, a silent intelligence in the kernels themselves. Her name was Barbara McClintock, and she would one day discover that genes were not fixed and immovable, but alive, capable of movement, change, and choice. Born in 1902, Barbara grew up questioning everything. She loved to work with her hands and hated to be told what she could not do. At Cornell University, she was drawn to genetics, then a new science still in its infancy. Most scientists studied fruit flies or bacteria, but Barbara chose corn. Its colorful kernels, she said, were a genetic notebook written in code. Under the microscope, she began to see the astonishing logic behind life. Each plant's color, pattern, and growth revealed how genes behaved. For most of her colleagues, chromosomes were rigid structures, simple carriers of inheritance. But Barbara's experiments began to whisper a different truth. By crossbreeding maize and carefully tracking every change, she discovered something no one had imagined: genes could move. They could jump from one place in the genome to another, turning traits on or off like switches. These jumping genes, or transposable elements, were her great revelation. When she presented her findings in the 1950s, the scientific world dismissed her. The idea that genes were mobile seemed impossible. "They thought I was mad," she said later with a quiet smile. "But I was only listening to the corn." Rather than fight back, Barbara withdrew from public life. She continued her research alone, without recognition or funding, guided only by her love for discovery. She often described her relationship with her plants as a conversation. She would observe them, they would speak back through their patterns. "I never feel alone," she said. "The plants are talking to me all the time." For decades, her work was ignored. But in the 1970s, as molecular biology advanced, scientists finally realized that she had been right all along. Her jumping genes were real, and they explained how cells regulate themselves, how mutations occur, and even how evolution adapts. In 1983, more than 30 years after her discovery, Barbara McClintock received the Nobel Prize in Physiology or Medicine, the first woman ever to win it alone. When asked how it felt, she said simply, "It's not so much a prize for me as it is for the corn." Her Nobel citation praised her discovery of mobile genetic elements, but her real gift was something deeper. She showed that life is not mechanical, but dynamic, a dance of change, conversation, and creativity. Barbara's notebooks, filled with precise sketches and poetic annotations, reveal a mind both scientific and spiritual. She once wrote, "If you know you are right, you don't care what anyone else thinks." She died in 1992, still studying, still curious. Today, geneticists build entire fields of research on her foundation, from cancer studies to biotechnology. Yet the image that remains most powerful is the woman in the cornfield, listening, patient, humble, attuned to the whispers of nature. Barbara McClintock didn't just decode genes, she taught the world that life itself speaks, if you're quiet enough to listen. Barbara McClintock, the woman who heard the corn speak.